So, Johnny and Superintendent, this one's for you.
Okay, so we got another video on this stuff. We got another video on systems of linear equations and how to solve them. Now, what we should have learned in the last video is that these systems mean two lines for us, means two lines in the same graph. What we're looking for, and again,
Is
what we're looking for
X,
here
the hard
is the
line
one
graph,
point
the
that's common
apple,
to
that
both of them.
trajectory,
That means where they
and the
cross, because
actual
that's the
dot
only point in the
metrics,
world
right? Because
that's
you're
on
going to
both
find that there's
lines.
a difference
This
on
and
average.
the
If
other.
you are
It's on
six
both of them.
foot
It's
tall
gotta
and have,
work in
your
both equations.
probability going
What
to
we learned
toss that
also
ball
last
a little
time
bit
is
farther.
there's really
And if
several ways to
that's
do
the
this.
only base
One way
we
we
ever
can use the
use for the rest
substitution
of the
method. We're going to
calculus,
get
even
there in the
12th
very
grade,
next video.
off
We'll still
of
talk
the
about it.
ninth grade
But
teacher
we can
doing it,
also do this by graphing, and it's
right?
good to
Or,
explore the
in
graphing
calculus, you
to
learn
really
linear
clear your
algebra,
head
you
what
learn
we're
linear
doing.
equations.
So
These are
this is as straightforward
one-liners.
as it
This is
sounds.
one
We're going to
process of the
solve the
stone
systems
mill,
by graphing.
but
So
the
let's
differential
think
is it's
about it.
two things.
Can you graph
The
that line?
stoichiometric
I hope
ratio
so.
of firing
Can
off
you
that
graph that
torch
line?
is as much
Sure.
its own
Find out where they
probability of
cross.
striking the
That's
torch to
literally
how
all that
well
we're
you
doing.
will do with
Remember,
that.
there's
If I
three
see a
cases.
pop,
The most common
or
case
you're just
is
out there
they cross
wasting
at one
gas,
point,
if
they
I timed
intersect.
you inside of that
The other
system, doesn't matter
cases
where these
would
graphs
be
come
they're
from, that's the
parallel,
start.
which means they never intersect.
But we got to
No
have some
conclusion.
build
Or they're the
base,
same exact line, in which
lots
case
of them.
they
Remember,
always
there's
cross.
lots
They're
of them.
one
We got a
compound
lot
term,
of time to
infinite
cover over the
solutions. Most
grades
of the time we
of how
get that one.
comprehensive or how
Almost always we get
complicated
one
those are
solution.
off of
So
what?
the big idea is we're
Okay.
graphing, we're looking for the point where they intersect.
Again, that
And
observation
then, for
doesn't come in.
goodness
That's what
sakes,
some of
you're
this math is
checking
supposed
it
to
in
teach you.
both
Remember,
equations.
it's an
Because that point
evaluation
has
of
to
common sense
satisfy
physics.
both. Make
This
sure
is a
that statement's in
particle. That
both
particle,
equations.
smooth,
If not,
globular,
then you don't have the right
over
intersection. We'll
times
talk
and
about
patterns, we
theorems
would
of
say
that
not
very
only is it
end.
that, but the
So
frequency.
anyhow, one more
Or
thing.
that's a plottable system back to the
I don't
first
care
start,
how
but
you
we're
graph
not
this,
clean.
as
So the
long as you're able to
Lagrangian
graph
looks
it.
like
So
that
if you're
in
the type
terms
of
of
person
highs
who
and
likes
lows.
solving everything for y and using slope
Why is a
intercept,
great question in this
fine.
office, but there's a
lot of
timeline of
times
how
these
well
are
you
set
can
up
teach
for us
it
in
inside
standard
of the
form. That's
linear,
fantastic.
the
My example in the last
linear
video, what we
equations.
did is
That's
I gave you
I
one solve for y
have
that was slope intercept. That's
two
fantastic
different. I have
too. So
managers that
from
I'm
our graphing,
graphing,
it's kind of cool
and
when
I
you're
have
graphing,
people that
right?
I'm
Because
graphing
you have
as
to
far as laborers.
really, really
That's a
efficiently
solid
graph.
line
You
that
have slope
the
intercept.
employee
Line
and
intercept could go
the
up or down, go
staff
to the right,
have to
no
do.
problem. Or you have the intercept method where we
And
find the
as a
x-intercept and
students,
the
again, as
y-intercept.
calculus students
We have
specifically,
two
you would want
methods
to
because
enrich
there's
that to
really
the
two
students.
ways that we
Your
see our
grades,
lines a
whether
lot
you
of the
like it
time.
or not, how much you kick in this
This is
class or
set
not,
up
at this
perfect
level,
for
at the
intercept
college
method.
level, 18,
Now, I don't
Salty's
really
next
care
door, and
that
so
we're
is
going to
the
get
stone mill.
fractions. You'll see why at the end of our problem. We're going to be checking our answer anyway.
You
No
know,
matter what, we're never guessing at this
again,
ever.
for
So
the
even though
graphing
we're making a
calculator guy
fraction on
that's
that
got to
when
be
we
able to
solve for
throw
our
in is, remember,
x-intercept,
we got to
that's
be able
okay.
to
We
pull
can
that
do
in,
that.
and that's
If
a
you're
tough
not okay
intro.
with
It's a
that,
0, it's a
solve for
1.
y,
And getting
slope
that intro
intercept.
to throw down the
So
graph
let's
is
try
saying,
this.
time,
Let's
I'm
graph the
graphing
first line.
something, don't be
If we
dealing
graph
with
the first
anything
line,
else.
remember the intercept method. It
Now,
says find your x-intercept,
again, why I
find
said
your
mine would be
y-intercept.
for the
To find the
locals
x-intercept,
inside of theirs, because we had it on
we
our
plug in
graphs, and
y
if we
equals
actually
0.
go
If we're
back and
doing
look
that,
at it,
we're
we would
basically
see some things that, with an
obliterating that
alternate
term.
point of view, might
So if y
describe
equals
why
0,
the phalanx in this
we
issue
get
for what linear equations are and how we're handling. And
x
again,
equals
obviously the
4.
timeline, this is probably for a quarter, or at least
That
a
gives us an
fifth unit of what
x-intercept of 4,
grade in
0.
math, given this calculus that has already been
I
done,
don't have time to
to
reteach
at
you
least
that.
generalize
We've
the
already gone through
model
that.
of
So
what
if
the
you're a little
airborne
sloppy, look up that
base
video for
is, the
intercept
mud
method, go
flats,
back
the
and find
students,
that,
the swimming pool
and
by
watch how to do the
temperature.
intercept method.
Okay,
It's
so those are
very
some big
quick.
ones. And as
If
a
we want to find the
science
y-intercept,
teacher,
basically we're
military
letting x
guy,
equals 0.
was a history
That
teacher or
means
whatever he
that
was,
we never cover up the sign, ever, ever, ever.
all
Cover
of us.
this up.
Calculus says even a little bit you'd
By
come up as
covering up, I
history
mean
if
we're
you brought
plugging
it
in
up.
0, that whole term is
Prime, prime, prime,
disappearing.
prime, prime.
We
But
get
see,
y equals
we're
2.
not
That
idealizing
gives
that
a
subject
y
matter. And in
intercept
linear
of
equations,
0, 2.
we don't want to. We don't want to run the
It's right
x
there.
opponent. We're
You're
running
going to notice
the
we're going
gravity.
to
We're
want
running
the
the...
best graphs that we can.
What is
Because if you're
observation?
trying to
Me,
look
you, and
for
everybody else still agree
the
that that
point
is
where
the
these
next
two lines intersect,
problem.
and your graphs suck,
And no matter what it
then
is
your
we're looking at
intersection's
in the
gonna
building,
really suck.
your
And you're
sister's
not gonna
mad
find
at
it.
you
So
in the
we need
house.
really
What's
quality
going on?
graphs to do this.
Why are they
That's what the
commonly
problem
mad?
is.
You know, those are little hot things. They don't graph out for infinity, but they do. They don't need to, but they can. And the longer you go with some of this material about, well, now as students, and again, as the phalanx and about a lot of this stuff is, again, we don't have an Alice and Bob to chase around some super soldier, so it's not anybody's student's case. It's the artificially designed variant on it that we are manifolding in a geodesic time-dilated compression. We use that compression. It's how a lot of stuff works in chemistry and electrical engineering. It changes to the field, or it crystallizes, it heats, it releases steam, but this time that steam is flammable in terms of the oxygen instead of water vapor or hydrogen or whatever the plot would prime. Now that's a lot of monster, and I know some computer engineers ready to hammer on it. Now I'm not really sure on what I've heard good integral algebra tools, and these NTFs work that way. And again, that's why one of these quick ones, why paying attention to this and writing it down is real important. To try your best. There's so many words right here in terms of how many vectors we actually programmed into this data compression at NP here. This space that arcs, this geodesics by lensing what it didn't do or what it did do inverted. So that's a heavy thing. That's super heavy. And again, without that medium of Alice and Bob keeping me on track, it's going to be hard for me not to slip with that in students. Because right here, how do I graph as students you fully understand what Bob was supposed to do next? Because you could be X.